Hello my dear students, welcome to my YouTube channel, that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today's topic for the lecture is the electronegativity. Electronegativity. What is this property? It is the ability of an element to attract the shared pair of electron towards itself in a bonded state. Whenever two elements forms a chemical bond, out of two, one is having the higher electronegativity, so due to which that one element with higher electronegativity will attract the shared pair of electron towards itself, and that's the property called electronegativity. Now, like electron gain enthalpy, electronegativity is not a measurable property. The exact value of electronegativity is always found with respect to the other element with which the concerned element is linked by the chemical bond. Let me give you an example. Let's talk about the three bonds. I am taking hydrogen bonded with the electron, hydrogen bonded with chlorine. On the other hand, carbon bonded with chlorine, and a chlorine bonded with another chlorine. Now let's talk about the first case. In first case, hydrogen is bonded with chlorine like HCl. The electronegativity of chlorine is much greater than hydrogen, due to which what will happen? The chlorine will attract both these electrons towards itself and will acquire a delta negative charge, and hydrogen will acquire a delta positive charge. So this charge separation in a covalent bond is due to the difference in electronegativity of chlorine and that of hydrogen. Now the difference between the both the elements will vary according to the different bonds. Now let's talk about the carbon and the chlorine. In case of carbon and chlorine, the chlorine is having the higher electronegativity than carbon, due to which chlorine will attract the again shared pair of electron towards itself and will acquire a delta negative charge. Take it like delta dash negative charge and a delta dash positive charge. Now electronegativity of carbon is much greater than that of hydrogen, so the charge separation in case of carbon bond chlorine will be lesser than the charge separation of hydrogen and the chlorine. So what I'm trying to show here, that the delta negative of chlorine in case of HCl is greater than the delta dash negative of chlorine in case of carbon bond Cl. So that means the value of electronegativity of chlorine is varying by different elements to which it is bound. Now let's talk about the chlorine bond chlorine. In case of chlorine bond chlorine, I'm talking about the third case. In case of chlorine bond chlorine, the electronegativity of both the chlorine is equal, so here the charge separation will not take place. So if we talk about the electronegativity of this chlorine with respect to the another chlorine will come out to be 0. Electronegativity of chlorine with respect to another chlorine will come out to be 0 because it's equal. So here that means what I'm trying to prove, that the electronegativity of chlorine will vary by the different elements to which it is bound in case of different bonds. Now that means the electronegativity is not a measurable property. The value of electronegativity will change with respect to the other element with which the concerned element is linked. Here I have taken the example of chlorine. The electronegativity of chlorine is much greater when it is bonded to the hydrogen. Electronegativity of chlorine is slightly lower when it is bonded with the carbon. Now let's talk about different numerical scales of the electronegativity. Now, however, the number of numerical scales of electronegativity have been developed. The very first is the Pauling scale, the second is Mulliken-Jeff scale, the third is Alfred-Roche scale. Now, Pauling scale. Pauling scale is a widely used. In 1922, Linus Pauling, an American scientist, assigned fluorine the value of electronegativity to be 4.0, which is maximum for the most electronegative element of the periodic table. That means in whole periodic table, the fluorine is the most electronegative element and will have the value of electronegativity to be the 4.0, which is maximum for the whole periodic table. Now let's talk about the factors on which the electronegativity depends. Now the electronegativity depends upon the following factors. The very first is the effective nuclear charge. The more will be the effective nuclear charge, the more attractive force the nucleus will exert on the shared pair of electrons, and hence more will be the electronegativity. Now let's talk about the another factor, the electron gain enthalpy. The more will be the electron gain enthalpy. That means the more is the tendency of an element to gain electron, and hence more will be the tendency of an element to attract shared pair of electrons also. So hence higher will be the electronegativity. So in both the factors I have talked about, first one is the effective nuclear charge. If the effective nuclear charge is there, that means they will the more attractive forces the nucleus that will exert on the shared pair of electrons, and hence more will be the electronegativity. And on the other hand, electron gain enthalpy, the more will be the electron gain enthalpy. That means the more is the tendency of an element to gain electrons, and hence more will be the tendency of an element to attract the shared pair of electrons also, and hence higher will be the electronegativity. Now let's talk about the very important term, the electronegativity. The electronegativity of any element is directly proportional to the non-metallic character. What do we understand by non-metallic character? It is a tendency of an element to gain electron. If the tendency of an element to gain electron is higher, that means non-metallic character is also higher, so that element will have greater tendency to attract the shared pair of electrons also, and hence higher will be the electronegativity. And on the another hand, and vice versa, electronegativity is inversely proportional to the metallic character. What do we understand by metallic character? The tendency of an element to lose electron, but electronegativity is dependent upon the tendency of an element to attract the shared pair of electron, or we can say the tendency of an element to gain electrons. So electronegativity is inversely proportional to the metallic character. More will be the metallic character, less will be the electronegativity. More will be the non-metallic character, more will be the electronegativity. So I'm repeating it again, more the non-metallic character, more will be the electronegativity. More the metallic character, less will be the electronegativity. So now let's discuss about the trend of electronegativity down the group. Now as we move down the group, I'm writing, as we move down the group, what will happen? The very first point, atomic size will increase. Second, effective nuclear charge will decrease. The very third point and the most important, metallic character will increase. Metallic character will increase, that is tendency to lose electrons will increase, because atomic size has also increased and effective nuclear charge has decreased. So the metallic character will increase down the group, and all these factors will contribute to the fact that electronegativity will decrease down the group. Electronegativity will very importantly decrease down the group. So now let's come to the trend of electronegativity across a period. Across a period, firstly I have taken lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, but I haven't taken the noble gas, that's neon. because the noble gases, the group number 18 has zero tendency to gain electrons. If they have zero tendency to gain electrons, that means they have also zero tendency to attract the shared pair of electrons. So the trend of electronegativity will not be applicable on group number 18. Group number 18 is not applicable in this trend. So I have taken up to the group number 17 because group number 18 elements have zero tendency to gain electrons and to attract the shared pair of electron towards itself. So let's talk about the period number 2. Now as we move across the period, that is from left to right, what's gonna happen? The very first point, the atomic size will decrease. The atomic size will decrease. So what will happen? Effective nuclear charge will increase. The very third point, the electron gain enthalpy will also increase. The electron gain enthalpy will increase. That means tendency to gain electrons will increase, and also the tendency to attract the shared pair of electrons towards itself will also increase. And finally we can say that across a period, non-metallic character will increase. Non-metallic character will increase. All these factors signify that across a period our electronegativity will increase. Electronegativity will increase across the period. So now let's discuss about this trend in the main periodic table. So here we have taken the Pauling scale values, in which you can see that the maximum value is of 4.0, which is of fluorine, and group 18 is not considered in this trend. Na means for not applicable, because group number 18 elements have zero tendency to gain electron and to attract the shared pair of electron towards itself. So now let's talk about specific groups. Let's talk about the group number 1. In group number 1 we can easily observe that down the group the value of electronegativity is decreasing. In group number 2 the value of electronegativity is again decreasing. So that means electronegativity decrease down the group. I am writing electronegativity decrease down the group. Now let's talk about the period. Now in case of period, when we are moving from left to right, you can see that the value is increasing. Now let me take the period number 3, left to right. We can easily observe that the value is increasing. So the value of electronegativity increase across the period. And very important to observe over here that the fluorine has the maximum value of electronegativity, that is the 4.0. In whole periodic table you can easily observe that any element is not having the electronegativity greater than 4.0. The fluorine is the most electronegative element and has the maximum value of electronegativity, that is 4.0. Now on the other hand, when we are discussing about the groups, electronegativity decrease down the group, and across the period electronegativity will increase. Electronegativity increase across the period and electronegativity decrease down the group, The fluorine is the most electronegative element with a maximum value of electronegativity, that is 4.0. So that's all for electronegativity. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.